Hey everyone, in this video let's take a look at question 102 binary tree level order traversal on Leetcode. This is part of our blind 75 list of questions, so let's begin. So in this question we are given the root of a binary tree and you want to return the level order traversal of its nodes, basically from left to right, level by level. You can see here the first level is just 3, the second level is 9 and 20, and the third level is 15 and 7, and you can see we're going from left to right. And so we basically want to return a list where we basically like group the items together that are on the same level. And so really, if you think about this, this is a graph type problem, right? It's not really a binary tree problem if you think about it. It's more of like a graph type problem. And there's multiple ways that we can go about solving this. We have a depth first search method. We also have a breadth first search method. Now, what kind of makes more sense here? Well, just remember kind of like the rule of thumb. When you want to explore something level by level, kind of the best way, the easiest way is to do a breadth first search. And we actually did this in one of our older problems. I think it was actually this one here. There's one on Leetcode where like if you start off here, you want to basically fill in the next value here, and then like on this one you want to like map this with this, and similarly you want to map like all of these together, etc. So it's kind of like a very similar problem to that in terms of like how we would approach this. But I guess one thing to notice here is whenever you want to do like these types of problems where it's like level by level, breadth first search is almost always the best solution here. Depth first search will still work, but the problem with depth first search is like you will go depth first, right? You will go all the way to the bottom. And so you will actually need to keep track of your individual level. And then once you are done processing the entire tree, you will basically have to like figure out, okay, which node was on which level. Maybe you store that in a hash map and then you basically aggregate all of those together. So that's why it's doable, but it's like it's a bit of pain. Easier, much easier is to do a breadth first search. So we can basically just process this level and then we will add in the 9 and 20, but we will still only process this 3 at the start. Then when we go to the next kind of level in the breadth first search, we'll process the 9 and 20 and we'd add in 9's children and 20's children. But basically we would only process a maximum of 2 nodes here, just the 9 and 20, even though by the time we process the 20, we already add in 2 more nodes. And then finally we'll process this level, and so then we'll get our answer of 2. So let's kind of take a look of how we can do this. And again, we've done this in the past with our breadth first search type problem. So let's just take a look of how we can do this, and I'll walk through the steps here. So first of all, we want to make sure that we're not empty, right? So if not root, then we'll just return an empty list. Otherwise what? So we need to make sure that in breadth first search we have our queue, right? And queue will start off at the root. And technically in breadth first search, depth first search, you need like a seen variable, like a visited variable. But it looks like here we're just heading downwards, right? And we won't have cases where like we're gonna visit nodes again because it's not like a connected graph if you think about it. So we don't really need like a seen variable here. So we can actually just omit that entirely. But what we can do is we can do something like while queue. Now, here was like what I was talking about by the level by level. We only want to process nodes on the current level. So for example, let's say at this point, if we go back, let's say 9 also had children, right? Let's say 9 also had children. So by the time we process 9, in our queue, we would actually have maybe this one child, let's just call the children like P and Q. So we would have child P, we would have child Q, and we would have, actually we'd have 20, we'd have child P, and we would have child Q. But the only thing we want to process is up to 20. We don't want to process P and Q because they're on a new level. So this is why breadth first search works, and we can just process this level by level. So assume like this is child P, and then this is child Q up here, right? So what we can actually do here very simply is we can just figure out the size of the queue, right? And then we can actually just loop. We don't really care what the I is, but we will loop through the size, and then we figure out the elements that are part of this essentially level in the breadth first search. That would occur is you go to q.pop, and I'll pop from the front. And now this maybe is like a 3, right? So I need to add this somewhere, right? So maybe I can call this like just L for list, or I can do like level, I guess. And then what I want to do is I want to level.append cur.val, right? And then I want to actually check. I want to check if cur.left, then I will add it to my queue, cur.left, cur.right. I will add that to my queue. And then what? Well, if we reach out of the loop, what does it mean? Well, it means we're done processing a level, right? It means we're done processing 9 and 20. even though P and Q is still in the queue, we're done processing 9 and 20. We're done processing a level. So once this happens, what we can do is we can actually append res, I will call my main variable. We can actually append to res. So I'll say res.append level. And that's pretty much it. And in the end, we just return res. So let's go ahead and run the example test cases and go ahead and submit. And that's all there is to it. All we really need to remember here is we are processing level by level. So that's why we have this for loop here, because we only want to process level by level. If this was a case where like instead of something like this, like we had like multiple children, right? We had like children here, we had maybe like more children here. Still, like the purpose of the level is to make sure we only process the 3, and then we process these in one go, and then we process these in one go. We don't want to process 3 and then all of this considering one go, because that would not be correct. Anyways, I hope this question helped. Look for the time complexity and space. It's basically just O of n, total amount of nodes. All right, thanks for watching.